In this video, we're going to talk about the inverse sine and inverse cosine functions and all the other inverse trig functions. So first, this graph here is the graph of the sine function. So the angle theta is plotted on the horizontal axis, and the result of the sine function is the vertical axis. So if you look at the sine function is not one-to-one. So you draw a horizontal line, it will pass through many points. So to be able to get the inverse function, what we do is we restrict the angle between minus pi over 2 to pi over 2. And so now if you look at the graph just in between the two dotted lines, this part is one-to-one. So that means that for every x value, there's exactly one y value. And for every y value, there's exactly one x value. And so we can do the inverse function. So here's the inverse function. And so the way you think of the inverse function is when you're computing the inverse sine of x, you think of the angle theta, so that when you apply the sine function, you get x back. And then similarly for the cosine function, to make it one-to-one, we restrict the angle to be between 0 and pi. And so to compute the inverse cosine of some number x, then you think of the angle theta such that if you apply cosine, you get x back. And then in both cases, the allowed x values are between minus 1 and 1. And then we can do the same for all the other trig functions, right? So to compute inverse tangent, you think of the angle theta such that if you apply tangent, you get back x. And then here the angle has to be between minus pi over 2 and pi over 2, and x can be anything. So for cosine, for cotangent, you think of the angle theta such that if you apply cotangent, you get back x. Here theta is allowed to be between 0 and pi, x can be anything. And then similarly for inverse secant and inverse cosecant. So let's compute some function values for the inverse trig functions. Okay, so here we're going to try to compute some function values. So in A, we want to find the inverse sine of 1/2. So we think of the angle theta, and the angle has to be in radians, such that if you apply the sine function, you get 1/2. So you'll know that sine of 30 degrees is 1/2, and 30 degrees is pi over 6. So sine of pi over 6 is equal to 1/2. So that means this is the value of the inverse sine. For inverse cosine, cosine of 0 gives you 1, so the angle should be 0. Here, cosine of pi over 3 gives you 1/2. So that means the inverse cosine of 1/2 is pi over 3. For inverse tangent of square root of 3, we have tangent of pi over 3 is equal to square root of 3. So that means the inverse tangent, the angle would be pi over 3 in this case. Inverse cosecant of minus 1. So we have sine of minus pi over 2 is equal to minus 1. So that means that cosecant of minus pi over 2 is also equal to minus 1. And so the angle has to be minus pi over 2. Here cosine of pi is equal to minus 1/2. So this is equal to pi. So we have to compute cosine of pi. Then cosine of pi gives you back minus 1/2. So this is equal to minus 1/2. Okay, if you have an expression where you mix the different trig functions with different inverse trig functions, this situation is a little bit more complicated, and so in these cases we want to use a right triangle to try to simplify these expressions. So let's see how we do that. So let's scroll down. Okay, so in this first expression, I try to compute the cosine of inverse tangent of x. Right, so if we think back to the inverse trig functions, we're always trying to think of an angle. Right, so this would be meaning to find the angle theta such that tangent of theta is equal to x. So this is representing some angle, theta. If theta is equal to inverse tangent of x, then this just means that tangent of theta is equal to x. Right, so we're thinking of the angle theta such that applying tangent gives you x. So now we can represent this expression using a right triangle. So imagine this is the angle theta, this is the right angle, so tangent is the opposite side over the adjacent side. So this side length is x, this side length is 1, and then we use the Pythagorean theorem to compute the length of this side. So it's this squared of this squared plus this squared, so 1 plus x squared. And now this expression is just cosine of theta. The cosine is adjacent over hypotenuse. So this is 1. So the adjacent side is 1. The hypotenuse is square root of 1 plus x squared. And so this is how you simplify this expression. So let's look at another example, see how we do this again. So again, computing the inverse secant will produce an angle theta. So secant inverse of x is equal to theta. But that means that we're looking for the angle theta such that if you compute the secant, you get back x. So we draw our right triangle. So secant is hypotenuse divided by the adjacent side. So we apply the Pythagorean theorem again. So now this would be the square root of x squared minus 1, because x is now the hypotenuse. And so now the sine is the opposite side over the hypotenuse. So sine of theta is equal to the square root of x squared minus 1 over x.